Okay, good morning to everyone. My name is Emiliano Fontan. I am product specialist, okay, and today's idea is to talk about ventilatory mode. The way we are working today, the same as yesterday, okay. I'm going to speak all the presentation, okay, and you can ask questions online, okay, using the question and answer section of the Zoom, okay, and my colleagues will answer all of your questions online, okay. So, today we are talking about ventilatory modes. At the beginning, I'm going to talk about a little bit, and I will do an introduction, okay, about some general concepts, important general concepts about ventilatory modes in order to understand in a better way the ventilatory mode itself, okay? Then in a second part of this training, I'm going to talk about all of the ventilatory modes in our ventilators, okay, especially the most important ones. So to start, the first thing we need to have in mind is the mechanical ventilation goals, okay? What's the idea of the mechanical ventilation? The idea is to generate a minute volume, okay, to deliver from the ventilator to the patient a gas, okay, with a control auto-inspire fraction, okay? So this is the main goal, but the ventilator have to do this without producing lung damage or hemodynamic interference or excessive work of breathing, okay? So that's the general idea of a mechanical ventilator. So what is a ventilatory mode? A ventilatory mode is the way in which the ventilator accomplishes the goals of the mechanical ventilation, okay? So it's a way that the ventilator do the main goals, okay? So in order to give you a clear classification of the different ventilatory modes, we are going to introduce you some definitions, okay, which are really important to have in mind in order to determine the ventilatory mode. The first one is the control variable, okay. This concept is really important because this variable controls the inspiration and it has a constant behavior during all the inspiratory time, okay? So you have this control variable and during all the inspiration, you know how, you will know always the behavior of this variable, okay? So the main variable that you can control are pressure, flow, or volume, okay? Physically, there are two ventilatory modes, basically, okay? One's related to the volume and the other one related to the pressure, okay? So this is talking about the control variable 2, okay? So when you control the volume, we are talking about a volume ventilatory mode, and when we control the pressure, we are talking about a pressure control mode. So pressure control modes. Here, the pressure is the control variable, and this variable is controlled by the ventilator. So what does it mean? It means that during all the inspiratory time, this variable will be constant, okay? So the ventilator tries to reach this reset inspiratory pressure and maintains it during all the inspiratory time, okay? So this is the control variable, but then you will have a non-controlled variable, okay? So if you control the pressure, you cannot control the volume or the flow, okay? So those two variables, volume and flow, in a pressure control mode will change, okay? So they will change according to the patient's inspiratory effort, according to the preset pressure, according to the respiratory impedance, okay? That means according to the compliance or according to the resistance, and according to the circuit characteristic, the patient's circuit characteristics, okay? So here we have two graphics, okay? In a pressure control mode. This one is the pressure time, and this one is the flow time, okay? So in pressure time graphic, you will see this is the inspiratory time, okay? So in pressure control modes, in the pressure time graphic, you will see a constant behavior of the pressure, okay? And the volume will change according to this pressure, okay? But you are not controlling the volume. And here you have the flow, okay? And this flow is variable, okay? You are not controlling the flow. So that's a general idea of a pressure control mode, okay? So then we have the flow or volume control modes, okay? So in these modes, the flow is the control variable, okay? However, in flow modes, volume is also controlled in an indirect way, okay? Because you know here the tidal volume is flow times inspiratory time. Yes, so if you are controlling the flow and the inspiratory time, you are controlling also the tidal volume, okay? Well, in all flow control modes, you can change the waveform, the flow waveform, okay, in order to generate, for example, different levels of mean pressure, okay? So you can change the waveform from a rectangular or a descending ramp, okay? Later, we are going to talk about how to change this parameter. So here we are controlling the flow and the volume. What happens with the non-controlled variables? I mean, what happened with the pressure? The pressure will change here according to, again, the same, according to the inspiratory effort, according to the preset flow or volume, according to the respiratory impedance, according to the patient resistance, the patient compliance, and the circuit impedance, okay? Here we have the graphics, okay, for a flow control mode. Yes, in this case, here we have the pressure and here we have the flow. So you are controlling the flow so that this graphic is constant. The flow here is constant during all the inspiratory time. Here we have the pressure, okay, And during all the inspiratory time, this pressure will be variable according to, for example, the compliance and the resistance of the patient. Again, here, in order to compare both type of modes of both classifications, we have the pressure, the tidal volume, and the flow graphics, okay, for a volume control mode and a pressure control mode, okay. Here in the volume control, we can see during all the inspiratory time a constant behavior of the control variable, I mean a constant behavior of the volume, and the pressure will be variable, okay. Then in a pressure control mode, here, those graphics, we have a pressure constant, okay, and the volume and the inspiratory flow will be variable, okay. You can see here the difference, for example, in the pressure or in the flow, according to what you are controlling. Right. So far, we have been talking about the control variables, and according to the control variables, we can classify the ventilatory modes in two big groups: the pressure control and the volume control modes. Okay. Now I'm going to talk about a little bit another variables. In this case, we call them phase variables, okay? And these variables will help us to understand a little bit more the different types or the different classification of the ventilatory modes, okay? So the definition is they are the signals used by the ventilator to determine when a respiratory cycle phase must start or end. What does it mean? It determines when starts the inspiratory phase, when ends the inspiratory phase, and so on. Okay, so we have 4 phase variables. The trigger one, okay, the trigger one indicates when the inspiration starts, okay? So this trigger can be by time, by pressure, by flow, or by volume. Then we have the limit phase variable. This is the amount that the ventilator will reach or will deliver. For example, in a pressure control mode is the pressure that the user is setting, okay? For example, pressure, flow, or volume, okay? Then the cycling variable is the signal when change the from the inspiration to the expiration phase, okay? So cycling can be by time, by flow, by pressure, or by volume. And then we have the base variable, okay, and in this case it's a pressure, it's the positive and expiratory pressure. So this is the variable which remains constant during all the expiratory time. So this is what I said before, okay, but in a graphic. In this case, we have a pressure control ventilatory mode, okay. This is the air pressure, and this is the flow. So this is the trigger, the moment when the inspiratory phase starts. Then we have the limit okay, in this case, the pressure set. Then we have the cycling, the moment when the ventilator change between the inspiratory and the expiratory, and then we have the baseline, okay, and what it is the the value which remains constant during the expiratory time, okay? So let's talk about the trigger, okay? Remember, the trigger is the moment when the ventilator starts an inspiratory phase, okay? So the ventilator can be triggered by time or by the patient, okay? So using this variable, we can do another classification. We can classify the ventilatory modes in a controlled ventilation if the trigger has been performed by the time, okay? Or we can classify the ventilatory mode in an assist or spontaneous ventilation, okay? If the trigger is by the patient, okay? So if we are in a controlled ventilation, okay, the trigger is by time, and the user is setting a respiratory frequency, okay? So in all controlled ventilatory modes, the user is always setting a respiratory frequency. Then we have the other ventilatory modes, which are assist or spontaneous ventilatory modes. In this case, the user is setting a sensitivity, okay? And this sensitivity can be set by pressure or flow, okay? So, of course, if we are here, we are talking about a inspiratory phase triggered by the patient. So, here we can see a graphic of two different triggers, okay? So this is the airway pressure and this is the flow. So if we are in an assisted ventilatory mode, okay, we will see this kind of graphic, okay? If you can notice, this is the baseline, okay, and because we are in an assist ventilatory mode, okay, we can see that the baseline goes down here, and this this depression, I mean, is the patient inspiratory effort, okay. So here is where you can see that the patient is triggering an inspiration. On the other hand, here we have a controlled ventilation, okay? Here you can not see that the baseline is going down, okay? We see that this baseline is constant and it starts here, the inspiration, okay? So here it's triggered by time, not by the patient. So the ventilatory mode is a controlled ventilatory mode, okay? Right, so we have already talked about the two biggest classifications: pressure control, volume control. Then we reclassify the ventilatory modes into a spontaneous ventilatory mode or a controlled ventilatory mode, okay? Now, we are going to talk about here a little bit about the sensitivity, okay? If you remember, when we are talking about the trigger, we can set an inspiratory sensitivity by pressure or by flow, okay? Then when we start to go, when we go through all the pneumovent ventilatory modes, I will show you how to set this pressure or this flow trigger, okay? So, pressure trigger. This is the pressure curve, okay? This is the baseline. And you are setting some sensitivity threshold here, okay? So, the patient needs to do or must do an inspiratory effort bigger than this threshold, okay? So, for example, if you are setting a pressure, an inspiratory sensitivity, an inspiratory pressure trigger of 5 centimeters of water, the patient's effort have to be bigger than this 5 centimeters of water in order to start an spontaneous inspiration, okay? In our ventilators, you can set this inspiratory sensitivity from 0.2 up to 20 centimeters of water, okay? Then we have the other inspiratory sensitivity, and it's by flow, okay? So now we're talking about the flow trigger. So in this case, for example, the user set an inspiratory sensitivity of 1 liter per minute. The ventilator will start to deliver base flow, okay, and it will measure this inspiratory flow and this expiratory flow. Here you can imagine is the inspiratory limb, and here is the expiratory limb, okay? So the ventilator will deliver certain amount of base flow here, and it will measure, then it will measure this value again, okay? So if, for example, there is no patient effort here, okay, that means that the patient is not taking any flow or any volume. The values that the ventilator delivers and measure in the expiratory part will be the same. For example, in this case, 4 and 4. But if there is a patient effort, what does it mean? That the patient is taking this flow is, I mean, the patient is trying to start inspiratory phase, okay? So in this case, for example, the baseline will be 4, the base flow will be 4 here, the patient will take 1 liter per minute, and in the expiratory port, the ventilator will read 3. So what does it mean? It means that the patient takes 1 liter per minute, so there is, we can assume, or the ventilator read this like an inspiratory effort, like a patient inspiratory effort, so it will start or it will trigger an inspiration, okay? Of course, the amount of flow that the patient needs to take from the ventilator can be a small one or a big one, and it will depend on the inspiratory sensitivity, okay? So you can set this inspiratory sensitivity from 0.2 up to 15 liters per minute, okay? So now we have a quotation here, some question about this sensitivity. So, considering our ventilator has a programmable flow sensitivity, which do you consider to be the most sensitive to the patient's effort? Okay, so remember the flow sensitivity you can set from 0.2 up to 15. Which one is the most sensitivity? And then what do you think should be the best value to be set? Okay, the default value, the lowest possible that does not generate auto trigger, or 1 liter per minute. Okay. So here the answer. Okay, the first one is 0.2. Okay, what does it mean? It means that the patient needs to take from the ventilator only 0.2 liters per minute in order to start a ventilation. Okay, in order to start an inspiratory phase. Okay, and then what do you think should be the value to be set? Okay, the correct answer is the lowest possible that does not generate auto triggering. Okay, so for example, if you are setting a really low value in the inspiratory sensitivity, maybe if the circuit patient moves or something like that, it can generate an auto triggering, or if the patient it's coughing or something like that, it can generate an auto triggering. So you have to set inspiratory triggering as low as possible, but you have to be careful to not set this value as low to generate an auto triggering. Okay, this is important. Okay, so let's continue. And here we have the other phase variable. Okay, so we have already talked about the triggering, we have already talked about the limit, and now we are going to talk about the cycling variable. Okay, in this case, is the end of the inspiration. Okay, it's when it changes between inspiratory to expiratory. Okay, so in volume control mode, okay, when they achieve the volume, it will change from inspiration to expiration. However, of course, it will take all the inspiratory time. And then in pressure control mode, for example, PCV or PCV, in PCV, this cycling will be performed by time, by setting a frequency, okay, or an inspiration time in fact. And then in pressure support, okay, the end of inspiration is by flow. Later, when we start to talk about the all the ventilatory modes, I'm going to explain this this end of inspiration deeply. Okay, the last variable is the baseline, okay, and in this case is the positive and expiration pressure, okay. This is the pressure which remains during the expiration, and the main idea is to avoid alveolar collapse, okay. So this pressure is an important pressure in order to keep all the alveoles open during the expiratory phase, okay? So those are the general ideas about all the ventilatory modes, okay? So you have to understand clearly that you can control only one variable. For example, the pressure or the volume, you cannot control both. So this is the main classification here, or the main concept that you have to keep in mind, okay? Then we have control mode and we have assist mode. Okay, so in control mode, the ventilator controls all the phases. Okay, the ventilator controls the inspiration, all the variables. Okay, all the phases variables. The ventilator will control the triggering. The ventilator will control the limit variable. The ventilator will control the cycling moment and the beep. In a spontaneous or in assist ventilatory mode, the patient will decide when start an inspiration and when it finish, okay, by the inspiratory sensitivity and the expiratory sensitivity. Both concepts I'm going to explain better in the ventilatory mode. So now we are starting to talk about specifically about our ventilatory mode. Okay, the first one is volume control mode, or VCV. Okay, the idea here is that the ventilator delivers a certain amount of tidal volume each breath. Okay, so the ventilator calculates the necessary flow to meet the demands of the set tidal volume and inspiratory time. Okay, so the flow and the volume breath by breath will be the same. Okay, it's the control variable here, but the pressure won't be. It will change according to the compliance and the resistance. This ventilatory mode is available in adult, pediatric, and neo patients category. So let's talk about all the variables here. The first one is the trigger one. This is an assist control mode, okay? So the trigger can be done by the patient. Yes, this is the assist part, or by time. This is the control, okay? Then the pressure. If we are in a volume control, the pressure is variable and influenced by the patient's respiratory mechanism. Okay, so what does it mean? The pressure value will depend on the compliance and the resistance. Okay, in this case, the volume is preset and warranted. Okay, and the inspiratory flow is controlled and fixed. Okay, you can change here between two different waveforms. Okay, here you have the two different waveforms you can set. This is a square or rectangular waveform, and this is a decelerating ramp. Okay, so here this is the ventilator screen. Okay, in the BCB mode. Okay, so here you have all the set parameters. Okay, all the parameters that the user must set. The first one is the tidal volume. Okay, this is the volume that the ventilator will deliver each breath. Okay, here you set the inspiratory time and the frequency. Okay, the inspiratory time and the frequency. And then here you set the other variables. For example, the PEEP, okay, the inspiratory sensitivity and the oxygen concentration. Finally, you set the flow waveform. In this case, is descending. Okay. So, because it is an assist control mode, you set a frequency here, and also you are setting an inspiratory sensitivity. Okay. Here, in this case, the inspiratory sensitivity is set by flow. Okay. Here you can see it's liters per minute. Okay, so this is flow sensitivity. If you double tap here, you can change between flow sensitivity to pressure sensitivity. Perfect. So you can also set, instead of tidal volume and inspiratory time, okay, you can set tidal volume and flow. Okay, it's a configuration that you can do. For example, if you want to set a big flow, okay, but in this case you cannot set the inspiratory time, so maybe the inspiratory time can be short or big. Okay, so these are some similar names. Okay, we call BCB, however, other brands call it IPPB or BCBAC, volume AC, BCCMB, BCAC. Okay, but the ideas are the same. The idea of the ventilatory mode or how does it work is the same. Okay. Well, now I have another questions about BCB. Okay, I will start the question. Please answer the question. The first one is if the patient's airway resistance increase, what will happen with the inspiratory pressure? And the second one is about the alarms. What do you consider to be the most important to program in BCB mode? Okay. So let's talk about the results with this image. So the first question is, if the patient airway resistance increase, what will happen to the inspiratory pressure? Okay, it will increase. Okay. Okay, because if the patient resistance is bigger, in order to deliver this amount of tidal volume, the ventilator needs to deliver more pressure, okay, for the same volume. Okay, and for example, if the compliance decrease in this second graphic, okay, it also will increment the airway pressure. Okay, and now about the second question, which alarm do you consider the most important? Okay, the maximum inspiratory pressure. This is the correct answer. Okay, why? Because here you control the volume, because we are in a volume control mode, but you are not controlling the pressure. Okay, so the pressure will depend on the compliance and the resistance. Okay, so you have to set correctly this alarm in order to avoid a really high pressure, which can lead in a lung damage. Okay, perfect. Well done. So the next ventilatory mode is PVC. Okay, we call it PVC. It's pressure controlled ventilation. Okay. Here the ventilator functions as a positive pressure controller. Okay, what does it mean? The pressure is set from the PCV parameter, and this value remains unchanged regardless of the patient compliance and resistance. Okay, so the ventilator delivers certain amount of pressure to the patient, and that's it. Okay, so it is available in adult, pediatric, and neo patients category. Let's talk about the different variables. Okay, this ventilatory mode, the trigger can be done by the patient. This is an assist, or by time. This is the control part. Okay, then the pressure here is controlled and preset. Okay, you are setting a pressure and the ventilator will deliver this pressure. So in consequences, the volume and the inspiratory flow will be variable, and it will depend on the preset pressure and the inspiratory time, and of course it will depend on the compliance and resistance. Okay, another parameter which is introduced in pressure control mode, okay, is the rise time. Okay, this control allows changing the time it takes to achieve the regulated control pressure. Okay, so this is like a time that inside the inspiratory time that the ventilator will take to reach the preset pressure. Okay, so this is the ventilator screen. Okay, and here we have all the parameters to be set. Okay, the first one is the pressure. the inspiratory time, the frequency, the beat, the inspiratory sensitivity, the oxygen concentration, and the rise time. Okay, here you must understand that this pressure is like a functional pressure. What does it mean? It's pressure over the PEEP. Okay, so the peak pressure will be this value plus this value. Okay, so here we can see peak pressure it's 20 when you are setting up 15 pressure here and a 5 pressure, 5 centimeters of water of peak. Okay. Similar names in other brands are PCMB, PCB, or pressure AC. Okay. Again, these names are the same that PCB. Perfect. Now I will do another questions to you. Here we go. So the first one is, if the patient's lung compliance decrease, what will happen to the inspiratory volume? And then, which alarm do you consider the most important in this ventilatory mode? We will take 1 minute for this question. Okay, I'm sharing you the results and let's talk about them here. So, if the patient's compliance decrease, okay, we have the same pressure because we are in a pressure control mode, but the tidal volume will decrease, okay, because the compliance is lower, okay. So with the same level of pressure, the lung can receive less volume, okay. And here, for example, if increase the resistance, okay, for the same pressure level, we will have the same result, okay. We will have a decrease in the tidal volume, okay. And the second question is about the alarm, okay. What do you think is the most important one? Okay, we are in a pressure control mode. We know the pressure level, we know the pressure value, okay? But we don't know nothing about the volume, okay? Because the value will depend in the on the compliance and on the resistance, okay? So here it's important to set correctly the minimum tidal volume, okay? Why? Because you need to deliver certain tidal volume in order to achieve a certain minute volume, okay, in order to guarantee a ventilation, okay? Wow. Let's continue with the next ventilatory mode. The next one is pressure support ventilation, or PSV, okay? This is a complete spontaneous ventilatory mode, okay, where the patient starts and ends the inspiratory phase, okay? So the patient will decide when start and when to start and when to finish the inspiratory phase, okay? The ventilator will only support the patient when an inspiratory effort starts, okay? So, because it's an spontaneous ventilatory mode, you have to set always the apnea time, okay? This ventilatory mode is available in adult, pediatric, and neo patients category. So let's talk about the different variables. Here, the trigger, as I told you before, it's patient only, okay? That's why it's 100% spontaneous mode. Then the limit is the pressure, okay? This is the control and preset variable, okay? Then the volume and the inspiratory flow will be variable and influenced by patient's respiratory mechanics and the preset pressure, as well as the inspiratory flow. And the difference here is that the cycling is doing by the patient, okay? So that's what we call the expiratory sensitivity, okay? It's by flow, and now I'm going to explain it better. So let's remind, this is the inspiratory sensitivity, okay? The patient needs to do an effort in order to trigger an inspiratory phase, okay? An inspiratory effort is this graphic decrease, okay? But the new variable here is the expiratory sensitivity, okay? This control adjusts the criterion for completion of the inspiratory period depending on the magnitude of the flow in progress, okay? So you set this parameter as a percentage of peak flow, okay? So let's remember, this is the moment when the patient decides to change between the inspiratory phase to the expiratory phase, okay? So you set here an expiratory sensitivity in a percentage of the peak flow, okay? So when the peak flow reaches certain percentage of the flow, okay? So here we have the change from the inspiratory to the expiratory, okay? So indirectly here, when you set this expiratory sensitivity, you are setting the inspiratory time, okay? So for example, here we have 3 examples, okay? 10%, 25%, and 40%, okay? So this is at 10%, of the peak inspiratory flow. If you are setting 40, for example, the inspiratory time will be lower. Okay? So the main idea here that you need to understand is one, okay, that the patient controls the inspiration and the expiration, when the inspiration starts and when the expiration starts. However, it's still a pressure mode, so the ventilator will help the patient delivering some preset pressure, okay? Here we have the ventilator screen for PCV mode, okay? PCV. Here you can see there is a backup, okay, or apnea ventilation. So if, for example, the patient does not start a ventilation or doesn't have an inspiratory effort, so the ventilator will change automatically to a control mode, in this case, VCV. Again, here we have all the parameters to be set, okay? In this case, pressure support, okay? It's a pressure. Then here you have the expiratory sensitivity, okay? A percentage of the peak flow in order to change between inspiratory to expiratory, and then all the common parameters, PEEP, sensitivity, oxygen, and rise time, okay? Similar names, pressure support, assist spontaneous breathing, or SPONT, okay? Again, other brands have another names for the same ventilatory mode. So, here we have another question for you about this ventilatory mode. And here we go, please answer the question. The first one is, if the patient makes an increased inspiratory effort, what will happen with the inspiratory pressure? And the second one is, what will happen with the inspiratory volume? Okay. Let's go with the results. So, pressure control, pressure support mode, okay? This is a pressure mode, okay? When the patient starts an inspiration, the ventilator will assist the patient delivering the preset pressure, okay? So, if the patient makes an increased inspiratory effort, okay, for example, instead of 1 liter per minute, it performs an inspiratory effort bigger, okay? The pressure, as you can see here, it remains the same, okay? Because it's preset, okay? every time you will have the same pressure. And what about the inspiratory volume? That means the tidal volume. The tidal volume, yes, it will increase. Okay? Why? Because this is a pressure mode. You always have to remember that pressure support mode is a pressure mode. Okay? So, in some way, you are controlling the pressure, but not the volume. And if you remember at the beginning of the presentation, we talked about that in a pressure mode, the tidal volume depends on the patient's effort. Okay, so that's why here the tidal volume increase. Okay. So we have already talked about the three most important ventilatory modes: volume control, pressure control, and pressure support. Okay, those three ventilatory modes are the most important, and you have to understand them clearly in order to understand the other ventilatory modes. Okay, so we will continue with the next ventilatory mode, and it is PRVC, or pressure regulated volume control. Okay, it's a controlled assist mode. Okay, which idea is to achieve a target tidal volume, okay, by an automatic regulation of the pressure controlled breath. Okay, so what does it mean? It means that the user will set a certain tidal volume to be achieved, okay, to be delivered, and the ventilator will start to modify in a controlled way, breath by breath, the pressure in order to achieve this volume with the lowest pressure possible. Okay, at the beginning of this ventilatory mode, the ventilator will deliver a BCP breath, okay, with a set target volume, and then it will perform an inspiratory pause. Okay, so the idea in this moment is to measure the respiratory mechanics of the patient in order to start with a certain level of pressure. Okay, and then this pressure will start to be modified automatically in order to achieve the preset tidal volume. This is the general idea of this ventilatory mode. This ventilatory mode is available in adult, pediatric, and neonate patient category. So here we have the different variables again. The trigger can be done by the patient or by time. It is an assist control mode. Then the pressure is controlled but not programmable. Okay, remember you are setting a volume, not a pressure. However, you still have here a lower risk of barotrauma because it's controlled. Okay, and the volume and the inspiratory flow, especially the volume, is preset, okay, because it's the target, okay, and the inspiratory flow will be variable. Okay, so this is a great graphic of this ventilatory mode. Okay, this is the first breath. Okay, it's a BCP breath, and then it starts the PRVC mode. Okay, so breathe by breath, the ventilator will increase or decrease up to 3 centimeters of water the pressure, okay, in order to achieve the tidal volume preset, okay. For example, we have this breath and we have a target volume of 10, for example, no, and it delivers a pressure. It delivers a pressure equals to 2 centimeters of water. Okay, so it measures then the tidal volume. If the tidal volume is lower, for example, it's 5, the next inspiratory pressure will be higher. Okay, the pressure will be, instead of 5, it will be 3 more centimeters of water. Okay, and then at the end of this inspiration, it will measure again the tidal volume. And so in order to achieve the tidal volume with the lowest inspiratory pressure. Of course, here you have to be careful about the alarm limits, okay? Because what happens if the pressure increase and increase and increase, but the tidal volume cannot be reached, okay? So the safety mechanism here is that the ventilator, okay, cannot increase automatically this pressure up to 5 centimeters below the maximum inspiratory pressure alarm limit. Okay, so for example, if you set this maximum inspiratory pressure alarm limit in 40, the pressure will increase automatically up to 35. Okay, but if with this pressure, for example, 35, the tidal volume, the preset tidal volume cannot be reached, the ventilator will give you an alarm, okay? And it will indicate you that this target tidal volume cannot be reached, okay? So it is important here to set correctly the limit alarm, okay? So here we have the general, here we have the ventilator screen, okay, for this ventilatory mode. Okay, so here you are setting a tidal volume. This is the target tidal volume. Because it's an assist control mode, you are also setting the inspiratory time as well as the frequency, and also you are setting here the inspiratory sensitivity. Then, of course, you have to set the PEEP level, the oxygen concentration, and the rise time. Okay? So, again, the idea of this ventilatory mode is to achieve a certain tidal volume with the lowest inspiratory pressure possible. Okay? That's the main idea. And the important thing here is to set correctly the pressure alarm limits, okay, in order to avoid to deliver a high levels of pressure to the patient. Similar names: adaptive pressure ventilation, PRV-CAC, autoflow, or volume control plus, VC plus, okay? Perfect. Next ventilatory mode is volume support ventilation, okay, or VSV. This ventilatory mode is a spontaneous ventilation mode designed to reach an objective or a target tidal volume by the automatic regulation of pressure spontaneous pressure support breathing. So it's like a mix between PSB and PRBC, okay? In fact, it's like PRBC, but 100% spontaneous mode, okay? So if I'm telling you it's a 100% spontaneous mode, I am telling you that here you are not setting an inspiratory time and you are not setting a frequency, okay? So you can say with this information that you're setting here an expiratory sensitivity, okay? So this is a mode in which the patient initiates and ends the inspiratory phase, okay? It is available in all patients category, in adult, pediatric, and neo categories. Let's talk about the different variables here, okay? So the first one, the trigger one, because it's 100% spontaneous ventilator mode, the trigger is by patient only, okay? The pressure is controlled here, but not programmable, okay? Remember, you are not setting the pressure, you are setting a target volume, okay? However, the breath are delivered in a controlled pressure way, okay? Volume here is preset as a target, okay? And variable according to the patient set. And the inspiratory flow is variable according to the patient. The cycling, okay, again, it's 100% spontaneous mode, will be performed by the patient, okay, and you're setting a flow. So it's exactly the same than PRBC, okay, but here you have like a pressure support, okay, so you are setting a tidal volume in this ventilatory mode, okay, and breath by breath, this pressure level will increase up to 3 centimeters of water, okay, in order to achieve the target tidal volume, okay? So it's the same that PRBC, but 100% spontaneous. Again, the safety limits about the pressure, it's the same that PRBC, 5 centimeters of water below the maximum inspiratory pressure alarm, okay? Here we have the ventilator screen, okay? And here you only set the tidal volume, okay? This is the target tidal volume. And here you have the expiratory sensitivity, okay? It's the same that in pressure support mode, okay? So you are setting a percentage of the peak flow, okay? And it's the moment when the ventilator change between inspiratory to expiratory, okay? Then the other variables are the same, PEEP, inspiratory sensitivity, when it starts an inspiratory phase, oxygen concentration, and rise time. Perfect. Similar names, volume support, spontaneous continuous positive airway pressure volume support, average volume assured pressure support, dynamic pressure support ventilation, okay? Perfect. Next ventilatory mode are synchronized intermittent mandatory ventilation. Okay, and these ventilatory mode are a combination of a mandatory and spontaneous breath. Okay, here you are setting a frequency which leads in a mandatory breath, okay? And this breath can be done by volume control, pressure control, or PRBC, okay? And then between mandatories and mandatories ventilation, the patient can start a pressure support ventilation, okay? In this mode, the patient determines the tidal volume and the frequency of the spontaneous breath, okay? It is available in all patients categories, neo, pediatric, and adult. So here it's going to be more clear. This is SIMB, volume control plus pressure support, okay? So the mandatory breath here and here are BCB breath, okay? So you're setting a tidal volume to reach here and to reach here, sorry, and the pressure will depend on the patient. And then between mandatory and mandatory breath, we have here pressure support ventilations, okay? So here we have the pressure support configuration, right? We also have SIMB, PCB plus PSB, okay? So mandatory breath are pressure control. So here you are setting a pressure control value, okay? And between mandatory breath, the patient can start a ventilation with pressure support. Okay, so here you are setting the pressure support and the expiratory sensitivity. Finally, we have SIMB, PRBC plus PSB. Again, mandatories here and here are delivered by pressure regulator volume control, and then between them you have pressure support ventilation if there is an inspiratory effort. Here some similar names: SIMB, BCB, BC, SIMB, B, SIMB, the same with pressure and the same with PRBC, okay? SIMB, PRBC, SIMB autoflow, or PRBC, SIMB. So, the next ventilatory mode available in our machine is non-invasive ventilation, okay? And this is basically a pressure control mode that combines pressure control and pressure support characteristics ventilations, okay? Spontaneous breathing with spontaneous pressure is allowed with the same characteristic that as those provided by pressure support mode, okay? In addition, here you can configure a respiratory rate, okay, to ensure the minimum ventilation, okay? So when you set or when you start the non-invasive ventilation, the ventilator operates with an automatic leakage compensation, okay? So it will be activated in an automatic way. It is available in all patients category, neo, pediatric, and adult. The important thing here about non-invasive ventilation is the interface, okay? Here you have to be really careful about which interface are you using? Okay, remember our ventilator is a 2 limbs ventilator. Okay, you have the inspiratory and the expiratory limbs. Okay, so the mask you are using how to be the closed one. Okay, so there are many masks with a leakage. Okay, with a leakage port. Those masks are not working in our ventilators because the system here try to be a closed system. Okay, and we have a 2 limbs circuit patient. Okay. Well, this is the ventilator screen. Okay, so as I told you before, you are setting a pressure support and a frequency as a backup. Okay. Perfect. Next, ventilatory mode. The next one is AVA or adaptive ventilatory assist. Okay, this is a closed loop mode, which idea is to guarantee a minute volume ventilation, okay, with a minimal respiratory work. So this ventilatory mode provides a pressure regulator ventilation and allows a smooth transition from a controlled ventilation to a completely spontaneous and ventilation, okay, in an automatic way. So, what's the idea of this ventilatory mode? The idea is to deliver a certain minute volume, okay, but trying to reduce as lower as possible the patient's work of breathing. Okay, it is only available in the adult and pediatric patients category. So some general idea about this ventilatory mode. Okay, it's called as a smart mode and a closed loop ventilatory mode. Why? Because you are only introducing 2 variables, and those are the patient's ideal body weight, okay, and with this ideal body weight, it's calculated automatically the ideal minute volume, okay, and then you are introducing which percentage of this minute volume you want to deliver to the patient, okay. It will depend, of course, of the patient, of the pathology, and so on. So the ventilator will start to measure the compliance, the resistance of the patient, and it calculates the expiratory constant time, okay? So with this information, the ventilator will calculate an optimal frequency using the Otis equation, okay? Using this equation, the ventilator can calculate this frequency, and with this frequency, it calculates also the ideal tidal volume, okay? So theoretically, with these parameters, the work of breathing will be the lowest one, okay? So this is the AVA graphic, okay? So this line represents the optimal minute volume, okay? This is frequency and this is tidal volume. So you can achieve this minute volume by different frequencies and different tidal volumes, okay? So according to compliance and according to the frequency and the resistance and the expiratory constant time, the ventilator will calculate this frequency and the volume in order to deliver to the patient the preset minute volume. Okay. There are some safety limits. Okay, in order to avoid lung damage. Okay. So these safety limits are based on the expert rules, okay, and they are automatically calculated, okay. So for frequency, we have these two limits, the limit C and the limit D, okay. The limit C is to avoid hyperventilation and the limit D is to avoid hypoventilation, okay. So the frequency can move from here to here, but not outside these values, okay, because it will be unsafe. And then the ventilator will calculate automatically also the maximum and the minimum tidal volume, okay, again, in order to avoid lung damage, okay. It will calculate this volume and this volume. A volume is the volume where you have overdistension of volume, and the volume is the lack of alveolar ventilation, okay? So the parameters, frequency and tidal volume, we moved automatically according to compliance and resistance inside these safety values, okay? But it will never go outside. So if the minute volume cannot be reached, okay, for certain patient's characteristic or wherever, the ventilator will inform you that it's not possible to achieve the set ones. Okay, this is the screen, okay, the ventilator screen. You set the ideal body weight at the beginning, okay, and it will, and you also have to set the percentage of minute volume. Then it will calculate all these parameters automatically, okay. You will have the same, the standard graphics, pressure, volume, and flow, and also here you will have the graphic that I showed you before. Again, this ventilatory mode is only available in adult and pediatric patients category. Similar names for this ventilatory mode is adaptive superventilation, ASV, or adaptive ventilation mode, AVM. Okay, to finish with ventilatory modes, with the most important ventilatory modes, I'm going to explain a little bit about high flow oxygen therapy. Okay, our ventilators have this ventilatory mode. Okay, the idea of this ventilatory mode is to deliver a high flow with a controllable oxygen concentration and a high humidity level, okay, in order to improve patient's oxygenation, okay. It is available in all patient categories, in neo, pediatric, and adult. And of course, you will need a different patient circuit here, okay. You will need the ventilator, and also you will need a servo control humidifier, a patient circuit with only the inspiratory limb, and a nasal cannula, okay. Remember here that the nasal cannula must not cover all the nose, okay? Only the 50%. It's mandatory to have a servo control humidifier in order to achieve the correct level of humidity and temperature, because if not, the therapy will not be successful. Here is the ventilator stream, okay? You only have to set the flow and the oxygen concentration, okay? For the flow, you can set it from 1 up to 80 liters per minute, and the oxygen concentration between 21 and 100% as usual, okay? So when you set both parameters, you start the ventilation and the ventilator will deliver high flow, the preset flow in a continuous way. Here you will have the monitoring of the oxygen, this one, the flow, this one, and the pressure, okay? This is the pressure in the circuit, but it's not the pressure inside the lung, okay? It's only a functional pressure for the ventilator, okay? This is important to understand. So I think this is it about ventilator modes, okay? Thank you very much for being here. It was a pleasure. The next one will be tomorrow, okay, at the same time. And my colleague, Nicolas Ceballos, will talk about monitoring, okay? He will talk about the respiratory mechanics, okay, about the measurements and about the monitoring numbers, okay? Remember, you have to inscribe in our site, tecmeglobal.com, okay? For further information, you can always contact us in our dedicated email, okay? It's technical.assistant@tecmeglobal.com. Thank you very much. And if you want to ask some question, you are available.